I am Dr. N. Lalithamani, Professor, Department of Mathematics, K.S.Rangasamy College of Technology, Tirchangur. Now I am going to give the lecture in Discrete Mathematics. Contents are proposition, connectives, tautology and contradiction, equivalence and implication, duality. First one is proposition. Proposition is nothing but a declarative sentence that is either true or false but not both. For example, Chennai is the capital of Tamil Nadu. What is the truth value? Truth value is true, right? Therefore, it is a proposition. See the next one. New Delhi is in America. New Delhi is in America is false. Therefore, it is a proposition. Then take the equation 1 plus 8 equal to 9. What is the truth value? True. Therefore, it is a proposition. The next one. Do you speak English? It is a question. Therefore, it is not a proposition. Obey orders. It is not a proposition because it is a command. Then take equation x plus 4 equal to 2. It is not a proposition because it does not have a constant truth value. Because suppose take x equal to minus 2 means the truth value of this equation is true. Right? Suppose take x equal to 1 means the truth value is false. So it does not have a constant truth value. Therefore, it is not a statement. If a proposition is true, then its truth value is denoted by T. If a proposition is false, then its truth value is denoted by F. Right? The propositions are denoted by uppercase or lowercase of alphabets. In proposition, there are two kinds: simple proposition and compound proposition. Simple proposition is nothing but a proposition which do not contain any of the logical operator or connectives. Simple proposition is also called atomic or primary or primitive proposition. Example, Ram is a boy. It is a simple proposition. Right? Next one, compound proposition or molecular or composite proposition. A proposition which contains more than one simple proposition and some connectives are called compound proposition. For example, Praveen and Kumar passed the examination. Praveen passed the examination is one atomic proposition and Kumar passed the examination is other simple proposition. These two propositions connected by the connectives and. Therefore, it is a compound proposition. Today is Friday or it is raining today. Today is Friday is one simple proposition. It is raining today is another simple proposition. Connect with two simple proposition by the connective or. Therefore, it is a compound proposition. Next one, connectives. Connectives is an operation which is used to connect two or more than two statements. It is also known as logical connectives or logical operators. In connective, negation. Negation is denoted like this. Right? Let P be a proposition. Negation P is also a proposition, which is denoted like this and read as not P. The truth value is P is true, then negation P is false. P is false, then negation P is true. The variable, one note, the variable, there are n variable means a proposition has n variable means there exists 2 power n truth values, right? So here p is the one variable, so there exists 2 power 1, 2 truth value, true, false. Negation p is vice versa. Example for negation is p denote today is Friday. What is negation of that? Negation p. So today is not Friday. Next one, conjunction. Let p and q be propositions. Then conjunction of p and q is also a proposition which is denoted by p and q. And it is read as p and q. Right? The truth value is both true means true, otherwise false. For example, it is raining denoted by p. Q denote I am getting cold. Right? What is the conjunction of these two statements, p and q? That is, it is raining and I am getting cold. Right? Next one, disjunction. Let p and q be propositions. The disjunction of two proposition is also a proposition. It is denoted by PRQ, which is read as PRQ. What is the truth value? There exists two variable PQ. So there exists 4 truth values: true, true, false, false, true, false, true, false. Then both false means false, otherwise true. Right? Example, P denote Raja appointed in Wipro. Q denote Raja appointed in HCL. What is disjunction of these two statements? P or Q. Raja appointed in Wipro or HCL. Next one, conditional. Let P and Q be two propositions. The conditional of P and Q is also a proposition which is denoted as P singularo Q, which is read as if P then Q. What is the truth value? True conditional, false is false, otherwise true. Example, Maria learns discrete mathematics. Q denote Maria will find a good job. Then what is P conditional Q? If Maria learns discrete mathematics, then she will find a good job. Right? Here P is hypothesis or antecedent part or premise. Q is called conclusion or consequence. Right? Take another example. P denote we do hard work. Q denote we will reach the goal. P conditional Q is if we do hard work, then we will reach the goal. Next one, biconditional. Next connective is biconditional. Let P and Q be two propositions. The biconditional statement of P conditional Q, biconditional Q is also a statement which is denoted as P biconditional Q, W arrow, which is read as P if and only if Q. The truth table for that is both, that is identical means true, otherwise false. For example, P, you can take the flight. Q denote you buy a ticket. P biconditional Q is you can take the flight if and only if you buy a ticket. Right? So P conditional Q is expressed in some other way, that is if P then Q. That is also P conditional Q. If P comma Q is also P conditional Q. Symbolic form of Q if P is P conditional Q. Q when P, Q unless P, P implies Q, P only if Q, Q whenever P. Q follows from P. Q is necessary for P. P is sufficient for Q. This is also expressed as P conditional Q. For example, express the following proposition as an English sentence. Let P, Q be the propositions. P. I bought a car this week. Q. I will drive in Friday. What is this? English sentence for negation P. P is I bought a car this week. What is negation P? I did not buy a car this week. What is P or Q? I bought a car this week or I will drive in Friday. P conditional Q is if I buy a car this week, then I will drive it in Friday. And negation P and negation Q. I did not buy a car this week and I will not drive it in Friday. Next example, using the statements R denote John is rich, H denote John is happy. Write the following statements into symbolic form. John is poor or he is both rich and unhappy. John is poor. We give the notation for John is rich is R. What is John is poor? Negation R. R. He is both rich and unhappy. Rich is R. Unhappy is negation H. Right? So next one, John is neither rich nor happy. So neither rich nor happy. So negation R and negation H. John is rich or unhappy. John is rich is R. R is disjunction. Thus unhappy is negation H. Happy is H. Unhappy is negation H. John is poor but happy. So John is rich is R. John is poor means negation R. And happy H. Give the truth values of P and Q as true and those of R and S as false. Find the truth values of the following. P, R, Q and R and S. What is Q? Truth value is true. What is truth value for R? False. True and false is false. P has truth value true. True or false is true. And S has a truth value false. What is true and false? False. Right. Next one. Truth value for P are negation P and negation R Q. Negation P is false. Negation R is true. So P has a truth value true. R has the truth value false. So negation P has the truth value false. Negation R has the truth value true. False and true is false. What is the truth value of Q? Given one as true. So false or true is true. P has the truth value true. True or false is true. Right. Next example, symbolize the following statements. If the moon is out and it is not snowing, then Ram goes out for a walk. First give the notation. P denote the moon is out. Q denote it is snowing. R denote Ram goes out for a walk. What is the symbolic form for first one? If, then. So conditional. In between if then is the moon is out and it is not snowing. The moon is out. P. And conjunction. Not snowing. So negation Q. Right? P and negation Q. Conditional R. Next one. If the moon is out, then it is not snowing. Ram goes out for a walk. If, then. So, conditional. The moon is out. P. Right? If it is not snowing. If. So, conditional. Not snowing. Negation Q. Then, Ram goes out for a walk. R. Right. Next one, it is not the case that Ram goes out for a walk if and only if it is not snowing or the moon is out. So it is not the case that negation. Ram goes out for a walk or if and only if biconditional. It is not snowing, negation Q, or disjunction. The moon is out, P. So symbolic form of the given statements are this one. Right. Next one, construct a truth table for the following statements. P, R, Q and R. So here 3 variables. So 2 power 3, there exists 8 truth values. True, 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 false, 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 false. Q has the truth value true, true, false, false, true, true, false, false. R has the truth value true, false, true, false, true, false, true, false. So what is P, R, Q? Both false means false, otherwise true. So to form this column. Next one, the resultant column. P, R, Q and R. And. So third, 3 and fourth. Both true means true, otherwise false for and. Right, next problem, negation P and negation Q or P, R, Q. So here 2 variables, there exists 4 truth value, 2 power 2, 4 truth values, true, true, false, false, true, false, true, false. Right, next form, negation P, negation Q, negation P and negation Q, P, R, Q. Then negation P and negation Q or P, R, Q. Right. So R means both false is false, and means both true means true, otherwise false. Conditional is true conditional, false is false, otherwise true. Biconditional is both identical means true, otherwise false. Right. Next one, tautology. Tautology means a proposition is called tautology if it is true for every truth assignment of variables. That is, resultant truth value is true means it is tautology. Contradiction means a proposition is called contradiction if it is false for every truth assignment of variable. Right? The resultant truth value false means that is contradiction. Neither tautology nor contradiction means it is called contingency. So negation of tautology is contradiction. Negation of contradiction is tautology. The problem, show that P or negation of P and Q is a tautology. To form a truth table, the resultant truth value is true. Therefore, it is tautology. Next one, P or negation P and Q. Form the truth table. In resultant truth value, fourth column, take the last column, the fourth row value is false. Therefore, it is not a tautology. Next, logical equivalence. It is denoted by like this, this. Let P and Q be two statement formulas. P is said to be logically equivalent to Q if P and Q have the same set of truth values. That is, P equivalent to Q if and only if P biconditional Q is a tautology. Implication means P implies Q if and only if P conditional Q is tautology. Equivalent means biconditional tautology. Right? Problem. Show that negation of P and Q and negation P or negation Q are logically equivalent. Right? So, to form the truth table, PQ, there exists 4 truth values, PQ, P and Q, negation of P and Q, negation P, negation Q, negation P or negation Q. Right? From 4th column and 7th column, the truth values are same. Therefore, negation of P and Q is equivalent to negation P or negation Q. Equivalent formulas. P and true is equivalent to P. P or false is equivalent to P. This is depends on the value of P. P true means true and true is true. P false means false and true is false. Right? So P and true is equivalent to P. P or false is equivalent to P. This law is identity law. P or true is equivalent to true. P and false is equivalent to false. Domination law. P or P is equivalent to P. P and P is equivalent to P. Idempotent law. Double negation law. Negation of negation P is equivalent to P. Commutative law. P or Q is equivalent to Q or P. P and Q is equivalent to Q and P. Associative law. P or Q or R is equivalent to P or Q or R. P and Q and R is equivalent to P and Q and R. Next one, distributive law. That is distribute with P, distribute with Q and R. So P or Q and R is equivalent to P or Q and P or R. P and Q or R is equivalent to P and Q or P and R. Then De Morgan's law, negation of P and Q is equivalent to negation P or negation Q. Negation of P or Q is equivalent to negation P and negation Q. Right. Next one, absorption law. P or P and Q is equivalent to P. P and P or Q is equivalent to P. Negation or complement law. P or negation P is equivalent to true. P and negation P is equivalent to false. Exploitation law. P conditional, Q conditional R is equivalent to P and Q conditional R. P conditional Q is equivalent to negation P or Q. P conditional Q is also equivalent to negation Q conditional negation P. P or Q is equivalent to negation P conditional Q. P and Q is equivalent to negation of P conditional negation Q. Then these formulas. Then biconditional equivalent formulas. P biconditional Q is equivalent to P conditional Q and Q conditional P. P biconditional Q is equivalent to negation P biconditional negation Q. Right? P biconditional Q is equivalent to P and Q or negation P and negation Q. Negation of P biconditional Q is equivalent to P biconditional negation Q. Right. Next, implication law. P and Q implies P. P and Q implies Q. P implies P or Q. Q implies P or Q. P and Q implies P and Q. P and P conditional Q is implies to Q. Negation P and P conditional Q implies negation P. Right. P or Q and negation P or R is implies Q or R. Right. Problem. Show that negation of P and Q conditional negation P or Q is equivalent to negation P or Q. So take negation P and Q conditional negation P or Q, which is equivalent to here R using associative law, negation P or Q. Negation P or negation P is equivalent to negation P. Then remove the conditional by using the formula P conditional Q is equivalent to negation P or Q. Right. Next step, negation is cancelled. We get P and Q or negation P or Q. Right. Using here and or using distributive law. P or negation P or Q and Q or negation P or Q. Then using associative law, here using associative law, P or negation P. What is P or negation P? True. True or Q is true. Then Q or Q is Q or negation P. True and anything is anything, that is negation P or Q. Here using the commutative law, negation P or Q, that is equivalent to, this one is equivalent to this one. Show that this one is tautology using equivalence law. So negation Q and P conditional Q, conditional negation P, which is equivalent to, eliminate the conditional by negation P or Q form, right, using distributive law. The next step, negation Q and Q is identity law, false, right. Next one, negation Q and negation P, conditional negation P, again eliminate the conditional by using this law, negation P or Q. So that is equal to this one. Negation of negation is Q, negation under R, negation of negation P is P, then negation of negation P, using associative law, Q or P or negation P, Q or true, Q or true is true, the resultant value is true, therefore it is given proposition is tautology, right. Next one, show that negation P and negation Q and R are Q and R are P and R equivalent to R using equivalence formula. We prove this by truth table or equivalence formula, here mentioning using equivalence formula, then we use the equivalence formula. So negation P and negation Q and R are Q and R are P and R. Here and R, so in between R, therefore we using distributive law, Q R P and R. Here and, so using associative law, negation P and negation Q and R. Here also and R take also by using distributive law, remaining term is negation P and negation Q or Q or P. Here using commutative law, Q or P is negation P or Q. Using De Morgan's law, negation P and negation Q is negation of P or Q. Right? Negation of P or Q or P or Q is true. True and R is equivalent to R. Right? Next one, well-formed formula. A well-formed formula is an expression which is a string consisting of variables, parentheses and connective symbols. For example, first one is well-formed formula, the second one is not a well-formed formula because here missing one variable and parentheses. Next one, duality law. The two formulas A and A star are said to be duals of each other if either one can be obtained from other by replacing and by R by and, false by true and true by false. Example, the statement A equal to P and Q. What is the dual of this one? Dual of A is denoted as A star. Dual of P and Q is P or Q. Take the next example. A is equal to negation P or negation Q or R and true. What is the dual? Negation P and negation Q and R are false. So show that negation of P and Q, conditional negation P or negation P or Q equivalent to negation P or Q. Then second one, using equivalence formula. The proving using distributive, associative, negation law, identity law, commutative law, idempotent law, double negation to prove this one. So from the first one, using duality law, we get the second result. Thank you for watching. Thank you very much.